Hey guys, we're going to do a couple problems on moles. And so for today, I'm just going to look at mass to particles. So I have the mole chart that's just going to help me to figure out how to navigate this. I also want to have my mole chart, my actual mole chart, as well as my periodic table because that has all the molar masses on them. Remember, molar mass is equal to, there's a little bit of a glare here, but is equal to the average atomic mass of an element. Okay, so let's say I have this question. I have how many atoms are in 3.15 grams of carbon? So I first want to figure out what I have here. So how many atoms? Okay, well, atoms, of course, is going to be particles, right? So I have that. And then I have 3.15 grams, so that's my mass. And this is also very important. I am dealing with the element carbon. So those are three pieces of information that we need. Okay. So let's figure out what we're given. So our known is 3.15 grams. Remember, if the number is attached to the unit, that's what I'm starting with. So grams refers to mass. So what do atoms refer to? Think about that. What would atoms refer to here? So atoms would refer to particles because you think, particles or atoms wouldn't be considered volume, wouldn't be considered moles, wouldn't be considered mass because it's not grams. Particles are the extra category that kind of fits the description of stuff. Okay, because this will always be in liters or milliliters, some kind of unit that has liters in it. Moles will always be in moles, and mass will always be in some type of grams, right? Whether it be kilograms or milligrams or normal grams, okay? Particles are going to be ions, atoms, molecules, etc. Okay, so if we're going from mass to particles, we have to think about our mole map. Mass to moles, that first step, we're following in this direction. We're going to divide by the molar mass, that's capital MM. Molar mass of carbon. And then once we're here, we're going to follow this arrow. We're going to multiply by Avogadro's number. So what I can do is I can first just write that down. So I'm going to start with mass and then divided by, okay, molar mass of carbon. I'll just put in parentheses of carbon. All right, so again, I'm just following this. Divided by molar mass of carbon. Don't worry that the moles are here. We're doing it all in one step. So divided by molar mass, multiplied by Avogadro's number, 6.02 times 10 to the 23rd. Okay, that will give us particles. So mass, 3.15 grams, divided by molar mass, so molar mass of carbon, okay, 12.011 grams per mole. And then you just bring this down times Avogadro's number. To save some time, I'm just going to do boop, boop, boop. Okay. So if you were to calculate that, what would you get? Remember, you'd put this in order. 3.15 divided by 12.011 times Avogadro's number, this whole thing. Remember too that the atoms, it would be atoms per mole, because then grams divided by grams cancel. These guys would cancel, and you'd be left with what you want. Okay, so Miss Bird just forgot her calculator. She's going to walk over to her very messy desk. Woo! Look at all this. Awesome. Okay, sorry if you're getting dizzy. All right, so then we go ahead and we plug this guy in here. So again, you start with 3.15. Okay, 3.15. Careful. Divided by 12.011. Don't round that. Times, and I always like to put in parentheses because when you're dividing, it will make a difference. So just get used to doing that. Equals Okay, so I have this whole number, and I also have, I'm going to write on here, I also have E23. Remember, that stands for times 10 to the 23rd. So if I'm going to round this to the tens place, 1 point, well, but here's the tens place. The number after that is a 7, so it's higher than a 5. We're going to bump up the 5 to a 6. 1.6 times 10 to the 23rd. 1.6 times 10 to the 23rd. What are my units? Atoms, carbon. Full answer, okay? It makes sense that we have, this is a giant number, guys. Think about this. If I were to move this decimal place over 23 spots to the right, that's how many atoms would be in about 3 grams. That makes sense. I want to have a large number because atoms are very tiny. So in 3 grams, I should have lots and lots of atoms, okay? In the future, we will be going over some of these other kinds. Particles to mass, okay? Remember, you would just reverse the process. Mass to volume. Now you're using this area. You're not using Avogadro's number. So really, it's just getting used to all